All right, we want to look at this list. We have natural numbers, whole numbers, integers, rational, and irrational. And there's a definition for each of those and an example. So what we want to do is look at this first problem. And what we want to do is list from this set, and a set is a confined set of numbers that fall in this category. So natural numbers are all numbers that are positive. So we have 0. Oops, let me go back here. And so for this one, we want all positive. So 0's not, by default, 0's not considered a natural number. But this number is our tricky one, because the square root of 9 is really 3. And so that's the only number that's positive in this set. So I'm going to erase this so I can do the next part. So now I'm going to look at integers. Integers are negative and positive. So in our set, -9, 0, and we already have radical 9 because that's a radical 3. Irrational numbers are numbers that don't repeat or end. So the only one that's a possibility would be either radical 10 or pi over 2. And since pi automatically goes on forever, pi over 2 would be irrational. And radical 10 we'll have to put into our calculator, so let me do that. And so radical 10 does end, so our only irrational number is pi over 2. Whole numbers are numbers that are positive and also include zeros. So we have 0, and we have radical 9, which we know is 3. Rational numbers are all numbers that aren't irrational. Since the only irrational is pi over 2, this set includes everything else. So -9, -1.3, 0.3 repeating, radical 9, and radical 10. And since they're all real, it would be E and D put together. Okay, well, if we're trying to compare numbers on a graph, anything to the left or going left gets smaller, and anything going to the right is larger. So the largest numbers would be to the right, and the smaller numbers would be to the left. So if we look at these two numbers and we compare them, the -4.5 on a graph is to the left of 1.2. So it's smaller. So we would use our inequality signs, which is the less than and the greater than sign. And we would use the less than because the alligator always eats the bigger number. So now let's compare this one. The -83 is to the left of the -5. So looking at in comparison here, we would want our greater than sign because -5 is actually greater than -83.